One of the fundamentals of robotics is using gears to achieve a goal. Gears are simple objects that mesh together to move rotational force from one axle to another. When you use gears on a robot, you might hear the words gear ratio being thrown around a lot, but what exactly are gear ratios? And what's so great about them? Because of differing sizes of gears, some tend to move faster than others. The greater the circumference or outside measurement of a gear, the faster its teeth move. This allows for some clever engineering. When one gear turns another gear of the same size, they will spin at the same rate. When one gear turns a smaller gear, the small gear will spin rapidly. And when one gear turns a larger gear, the larger gear will turn very slowly. So when you need to move a robot part fast, just use a large gear to turn a small gear. And when you need to move something slowly, all you have to do is use a small gear to turn a large gear. So that's all well and good, but we still haven't figured out what this has to do with gear ratios. A gear ratio is the measure of how many teeth are on the gears you're using. The measurement is expressed as a ratio, or a fraction of two numbers, where one number is the number of teeth on the original gear, and the other number is the number of teeth on the gear that is being driven. In this model, there's 60 teeth on the original gear, and 60 teeth on the driven gear. Therefore, the gear ratio is 60 to 60. This ratio can be simplified as 60 divided by 60, or 1 to 1. In this model, there are 84 teeth on the original gear, and there are 12 teeth on the driven gear. Therefore, the gear ratio is 84 to 12. This ratio can be simplified as 84 divided by 12, or 7 to 1. And finally, in this model, there are 12 teeth on the original gear and 84 teeth on the driven gear. Therefore, the gear ratio is 12 to 84. This can be simplified as 12 divided by 84, or 1 to 7. The gear ratio doesn't just mean teeth. It's a measure of how fast the driven gears will spin. In a 1-to-1 gear ratio, the driven gear will move at a normal speed. In a 7-to-1 gear ratio, the driven gear will move 7 times faster than the original. And in a 1-to-7 gear ratio, the driven gears will move at 1/7 the speed of the original gears with 7 times the torque. Let's test your knowledge with a few examples. In this model, a 12-tooth gear turns a 36-tooth gear. What's the gear ratio? If you said 1 to 3, then you were correct. In this model, a 36-tooth gear turns a 60-tooth gear, with another 36-tooth gear in between them. What's the gear ratio? The gear ratio is 3 to 5, even though there's a buffer in between them. This is a simple way to implement and determine gear ratios, but they can be made much more complicated in real robotic systems. Be sure to experiment for yourself to see what you can do with gears.